So as mentioned, my name is Matej Biček. I'm coming from ELAPHE Propulsion Technologies. So as already mentioned, we are, let's say, for Slovenian environment, a showcase for a story that was funded by EIT. In our case, it wasn't EIT manufacturing, but EIT InnoEnergy. So we obtained two successful fundraising activities, let's say. The first one was 10 million from a strategic investor from China in 2015. And in 2020, we continued with EIT InnoEnergy. And the following slides will be used to also tell you a bit how this capital was invested and why we were acquiring it. So ELAPHE Propulsion Technologies is not anymore a startup company, I would say, but more a scale-up. Currently, it's a bit more than 150 employees. Headquarters is in Slovenia. We have a joint venture company in Hangzhou, China. About 15 people, in addition to the Slovenian colleagues, are located in Hangzhou. We are mainly focusing currently on western part of the world, so the majority of customers are coming from US and Europe. And our core product is in-wheel motor. So we are putting the motor where it's needed. So actually, we only need the torque and the rotation inside the wheels. And everybody that is somehow connected with automotive, or at least the current electric mobility, knows that the trend is going from having one motor, now electric motor, to two motors or three motors or even four. So Tesla, being the most popular one, started with one motor under the hood. Now you can buy Teslas only with two motors, the most performant ones with three motors. The upcoming, let's say, Cybertruck model already has four motors. They are a bit different than what we are doing. So these motors are high speed. They have a reduction gear, transmission parts. In our case, we put the motor inside the wheel. So that means the motor is spinning at a lower RPM, but it also needs to deliver much higher torque. For this reason, we have, let's say, products that are meeting different requirements for these different vehicle models. Because also our customers have very, very different requirements. Either this is lower ground floor, more packaging for passenger, more packaging space for energy source, for passengers, or increased vehicle dynamics, because the response time of in-wheel motors having specific rotational sensors integrated is much better than with conventional ABS solution. So your car is able to brake faster, and it's also able to generate torque much faster. So from, let's say, different OEM requirements, this can also be sold as like an additional feature for the upcoming electric vehicles. So these are just some of the, let's say, benefits that we are selling to our customers. It's never the case that one customer wants all of them. It really depends on the vehicle type and on the customer, what they're looking for. On the screen, you're seeing two of our showcase vehicles. So we intentionally wanted to showcase two very different segments. So one is a converted Audi R8. So this is like a supercar with very high acceleration. The other is a BMW X6, so let's say coupe variant of a SUV. They both have identical motors from ELAPHE, so 4 in-wheel motors in every wheel one. Each of them can produce 110 kilowatts of peak power and 1,500 Newton meters of torque. So altogether, this is 440 kilowatts or 600 horsepower per vehicle and 6,000 Newton meters of torque. And this can be delivered almost instantly, so much, let's say, differently as with conventional vehicles. We don't actually cover only the motor itself, but we are offering to our customers a turnkey solution. So with every electric motor, there comes also power electronics, so the battery is giving out DC, you need AC on the motor, and you also need to have a control logic. So either you have a computer, currently we have one computer in a vehicle, but let's say legacy OEMs like to complicate, so a BMW has 18 computers, Tesla has one computer, and let's say future mobility is going into simplifications. So what we are offering with the propulsion control unit is exactly this what I'm telling you. So the control unit is able to communicate with inverters, consequently with the motors. You can integrate advanced functionalities like torque vectoring, and every motor can function optimally, whether you decide to drive in a sports or an economical mode or something in between. So with this, let's say, hardware and software parts on electronics, we can really cover everything. With some projects, we are also covering the battery pack, so really a turnkey solution for our customers. Let's say, core benefit or what we bring to the table for our customers is our know-how and the intellectual properties. So we are having currently 18 patents within 11 different patent groups. So this is also the core of the company where it all started from. So the company was established formally in 2006, and we immediately started developing very advanced electromagnetic design. And later on, we updated it with very good mechanical design and patented also these solutions. So currently, with our motors, it's possible to use conventional or stock mechanical brake, hub bearing, caliper for the mechanical brake, stock suspension, rim, pneumatic tire. And it turns out that our customers, so the OEMs, really want to have the freedom to choose whichever tire, rim, bearing, disc brake they want. They only want to integrate the stator and the rotor, which is what we are as the only company bringing to the table. So a few words about the current trends. So obviously in the last 10 years, let's say since Tesla came to the market with Model S, the market exploded. All of the OEMs now already have at least one, if not more, models. And it's going more and more into this direction. So when companies like Volkswagen put out, let's say, a press release that they will electrify everything up to 2030, that means something, and others need to move. And with our, let's say, solution, it was, I would say, for the first 9 years or let's say up to 2015, since we obtained this first investment round, it was more like an R&D company or a spin-off of a university. So a lot of scientists, a lot of PhDs, master's degrees, etc. And with the initial investment that we obtained, so this 10 million euro, we invested into the validation of the product. So since the motor is located in a rim, you can imagine it needs to be designed in a way to really be durable, to survive all the mechanical loads, the thermal loads, all the dynamics that the vehicle is exposed to. And after validating the let's say, stock motor, like we call them, so we designed with our own requirements some off-the-shelf motors, we are now using also this knowledge that was gained for other tier ones, so for companies that are building different electric motors, not only in-wheel, and we are offering them also a service. So this is, let's say, one part, it's a small part of the company, but also this IP can also be used as a stream for the generated revenue. These are just some of the companies that you might came across. Let's say, new names are like newcomer OEMs that are willing to, let's say, take over innovative products much faster. They also have very ambitious plans for start of production, so they invest less time into R&D. But on the other hand, they're also pushing companies like we are to deliver motors in higher series quite fast. And then there are some legacy OEMs like Kia, Nissan, Lexus, etc., that are also already considering in-wheel motor as the next big thing. So they already have demo vehicles with similar solution or with our solution. So currently we are very strong in global sense, working on all continents, I would say. Unfortunately, we are working under strict NDA, so we are able to discuss about, let's say, the newcomer OEMs who are also using every press release they can obtain, but with conventional OEMs, it's a bit different. Regarding the validation, so this is like one environmental chamber where we expose our motors from -40 to +95 degrees, being the let's say, worst case conditions from the thermal point of view. And we load our motors for different driving cycle scenarios. So this is just one case of a validation that we are doing, like a scenario or like an option, how we also generate the current revenue. We offer also bottom-up development of our motors, and this generates about 2/3 of our revenue currently. In the last year, it was 15 million euros, and about 1/3 was actually EBITDA, so quite successful year. Also, in the same time, we are generating, let's say, 1/3 from production. So currently, we are discussing about thousands of motors. Last year, I mean, the capacity was 2,000 motors with the takt time that we achieved with our manufacturing capabilities. We produced about 700 motors during the complete 2021. But based on our award letter that we already obtained and will be public actually in June already this year, we will really need to reduce the takt time to increase the production capacities and also do something on the infrastructure. So currently we're located in Ljubljana, actually in 5 different buildings. So it wasn't the best industrial zone where we started our company, or the company just scaled up too fast. So first, we have a lot of office floor, we have a lot of production floor, we have machining centers, lathes. You can imagine also the assembly plant that also takes a lot of ground floor. And if the infrastructure is not appropriate, you cannot really expand that fast as we hire people. So this is our next project. So currently we have signed a contract last Friday, so we will be purchasing land just close to the airport. So these are just some logistic companies that are already located over there. And we will be moving in the end of 2023 or beginning of 2024. So the construction permit should be obtained in August, and the construction works should start in November this year. There is a huge volatility, as you know, on the market, and of course some tolerance can be met. But this is initially the plan, how to reach larger production capacities that are expected by our customers already. So this is the current team. I would say from 150 people, about 110, if not 120 engineers, electrotechnical physicists, mathematicians, mechanical engineers. So a lot of know-how, let's say, is generated on a daily basis, a lot of highly skilled people. Actually, in the last year, we hired 75 people, so we are expanding quite fast. We employed a lot of people from foreign countries. Currently, we have people from 12 different countries. And the plan for this year is to go up to 200 people. Of course, the manufacturing part is very important for us. We have the manufacturing capacities for machining and for assembly, and different processes like curing of epoxy resin, etc., in-house. For some, let's say, customers that are already willing to obtain motors in a higher quantity, we are already outsourcing, especially the machining part. Currently, it is quite demanding, I would say, to obtain all the capacities in Slovenia, so we are also searching abroad in Europe, of course, but also in China with, of course, some restrictions. For the last slide, maybe one interesting thing. So this is our in-wheel motor in section cut. You can see a standard or stock rim pneumatic tire, hub bearing, disc brake. The green part is actually only our motor. So it's very compact, very slim. You can integrate it into any wheel that you see on the street. So the stator is this a bit thicker part, the rotor is a bit thinner. So this is on the right side, what we are doing in what we are, let's say, the pioneers. Well, pioneers to some extent. The initial hub motor was patented about 130 years ago by Ferdinand Porsche. So we're not the first, I would say. And on the left side, this is the oldest wheel that was found, and it was found in Slovenia, Barje, about 20 kilometers from our company. It should be around 5,000 years old. So it seems wheels are in our DNA. Thank you.
So you mentioned some of the advantages of the technology, and it's been on the market for some years. And it would seem logical that the industry would go into this direction. What would you say are some disadvantages, or what are the reasons that the technology is not adapting this technology faster?
So in the initial years, let's say when we were in this R&D phase, it was the most important part to do a product that is durable. So sealing on high diameter while generating minimum amount of losses is the first thing, let's say. And we developed in-house standards for the design validation part. So this was like at least 5 years of work of very scientific approaches, you know. So once the validation part was covered, then we needed to showcase the technology, you know, and even that takes time. And the EIT, Energy round supported us, especially in the business development part. So for example, this year we were the 4th time on winter testing, so we expose our vehicles to extreme conditions. We were twice in China, in Heihe, this is northern part of China, where temperatures go up to -40. And this year and in 2020, so we skipped 2021 because of COVID, we were in Arjeplog, which is the most known resort in Europe, in Sweden, where we also exposed the vehicle to severe maneuvers on frozen lakes. You know, there is ice like 1 meter thick, and all the major OEMs come and visit. They test their vehicles, and you have the opportunity to also showcase your vehicle, you know. And one of the benefit is the torque vectoring algorithm, you know. So they were driving at like 110 kilometers on frozen ice, maneuvering the car like there is asphalt ground, you know. So the torque vectoring, where each wheel can independently work and sense the grip, is extremely beneficial, you know, at least for some applications. Of course, not for all, but at least part of them are well covered.
So it's still experimental technology, or would you say it's ready for mass production?
With 3 customers, we are already starting mass production. So the validation, or let's say in automotive terms, we came to sample C. So let's say sample A is the proof of concept, sample B is the validated technology, sample C is the industrialized. So we also have a customer that has huge facilities to manufacture, and we went forward with a licensed business deal, so they will be able to produce the motors in high quantities in their facility. And the motor also uses high industrialized technologies like high pressure die casting for housing components.
Great, thanks.
Thank you.